Hello everybody, welcome to the first day of 4.8, the quadratic formula. You can see our target and what we're going to do. So the quadratic formula requires us to have values of a, b, and c be real numbers, and a cannot equal 0. And this is our quadratic equation, ax squared plus bx plus c equals 0. Again, key being that it has to equal 0. If it's not equal to 0, then you cannot use the quadratic formula. But remember, this is standard form of a quadratic. Okay? A cannot equal 0, because if a equals 0, then that's 0 times x squared, and then I just have a linear equation. So it has to be a number greater than 0 or less than 0. It cannot equal 0, otherwise it's not a quadratic. So again, this is standard form of a quadratic, and if that's standard form of a quadratic, then we can use the quadratic formula to solve a quadratic. Some of you remember this, and you may remember it as recorded to the song Pop Goes the Weasel. Okay, and what I want to make sure we do is I want to talk about this symbol right there, and a lot of people say that that's negative b. I would like you to say it is the opposite of b. The reason being, if I have b as negative, then there would be a positive value there. And that can be confusing if you're thinking negative b. It's the opposite of b to make it work. All right, so the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. And then if you think about Pop Goes the Weasel song, it was all over 2a. All right, so hopefully my singing didn't break any windows in the background of your house. So let's move on and let's use it. All right, so based on this equation and thinking about ax squared plus bx plus c, all right, well in this case the a value is simply a 1, so a is equal to 1. B right there would be a negative 5, so b is negative 5. And c is negative 7. And again, we're using the quadratic formula. X is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so what we're going to do is it'll be x equals, it's an x equals equation. The opposite of b will be 5 plus or minus the square root. Now let's analyze what is going to go into this position right here. That is b squared. If I square this value, that would be a negative 5 in parentheses squared, which will be a 25. So understand that in this position, there will always be a positive number. I have to have a positive number in b squared. Should not be negative. I think it'd be easier to write plus negative 4 multiplied by a, which is 1, and c, which is negative 7. All right, the reason why I want this to be plus a negative 4 is now I know I have a negative 4 times a negative 7, which is going to be positive 28. So now I would have 25 plus 28 under that radical. Okay. Now, I'm sorry, I forgot to do 2 times a on the bottom, which is a 1. So 2 times 1 is 2. So now I would have 5 plus or minus the square root of 25 plus 28 all over 2. And 25 plus 28 is 53. So now I have 5 plus or minus the square root of 53 all over 2. And what I'd like you to get used to practicing is separating this denominator. So it's really 5 halves plus or minus the square root of 53 over 2. So then that would be your answer. I would like this answer here over this. If you separate your answers, that is how you would reduce the fraction, and that is also how you write it as like we did the other day with complex numbers. All right, I'd have this is the real part. That would be, in this case, the irrational part, but that is how I'd like you to split the answers. So let's try one more example. On this equation, notice it looks a little different. But remember, we need it to be ax squared plus bx plus c equal to 0 in order to use our quadratic formula. So to do that, I have to subtract the 17x from both sides and add the 25. And if I do that, I will get 16x squared minus 40x plus 25 equal to 0. There is my terms. Those are my values. And again, A is 16, B is negative 40, and C is 25. So when I put that in the quadratic formula, x would equal the opposite of b, so 40 plus or minus the square root. Remember, I'll always have a positive term right there, so negative 40 squared is going to be positive 1600. And I think it's easier to write plus negative 4 multiplied by 16 multiplied by 25. All over 2 multiplied by a is 16. So then x is equal to 40 plus or minus the square root. It'd be 1600 plus, and if I did these values here, negative 4 by 16 by 25 would be negative 1600. And then all over 32. And if you take a look here, that's a 1600 plus negative 1600, that just becomes 0. So 40 plus or minus the square root of 0 all over 32. Now, you can take the square root of 0. The square root of 0 is, in fact, 0. So now my numerator is 40 plus or minus 0 over 32. Well, if you get this to work out, if you get this square root to work out so it's an even number, a whole number, you then add the numerator. So 40 plus 0, well, that's just 0, over 32. So x would be 40 over 32. If I did 40 minus 0, that's still 40 over 32. So it's still 40 over 32. However, I cannot leave my answer as that value because that's not reduced. So in this case, x is equal to, divide each by 8, we would have 5/4 is my value of x. Well, how could you have a quadratic, which is supposed to have 2 x-intercepts, have only 1 x-intercept? That's what we're going to look at next. But this is how you use the quadratic formula, and that's what the answer would be this time. So think about a parabola. How many real solutions would there be? Well, if you think about an xy axis, what's one way that a parabola could cross the x-axis? Well, I could have it cross like this. It could cross like this. It could cross, barely like that. And all those situations, notice that there are 2 x-intercepts on all those. Okay? Well, what if I had only one real solution, like the last example we just did, where the answer was just x equals 5/4? How was that possible? Well, that would be the case if the parabola touched the x-axis and went back up, meaning that the x-axis is in fact the vertex. Or I could have had the x-axis where it came up like this and came back down, where it only touches it once. And that is called the graph being tangent to the x-axis, if you remember that term from geometry. Now, the other possibility is that there are 0 real solutions, where I have a parabola where the vertex is right there, and it moves up from the vertex. That has no real solutions, because it doesn't cross the x-axis. Remember, a solution is just like a 0, it's just like a root, it's just like an x-intercept. Well, the other situation I could have is I could have the vertex there, and it goes down and opens down. That also would have 0 real solutions because there are no x-intercepts. And are you ready for the reason why? There are no x-intercepts on these 2 graphs because the x-intercepts are imaginary. All right, a little key in from yesterday in 4.6. These 2 blue parabolas have imaginary x-intercepts because they never actually cross the x-axis, and that's why they're imaginary. The way you can determine this is what's called the discriminant, okay? And the discriminant, you can see, is just the expression under the radical sign. The discriminant is simply the b squared minus 4ac. If you just have to figure out what the discriminant is, that just tells you how many solutions. The discriminant doesn't tell you the answer of the solutions, it just will tell you how many solutions. So there's different types of questions you're going to see. So one type of question is going to be to solve the equation. If you solve the equation, you use the quadratic formula. If you're just asked for how many solutions, you only need to do the discriminant. Now, you could always just solve the equation every single time, but if you're under a time crunch, like on the ACT, only having to find the discriminant would be a time saver. And so what you have here is this table for how you find the value of the discriminant. Now, if the value of the discriminant is greater than 0, meaning that it is positive, a positive discriminant, that means it has 2 real solutions, and they are wherever the x-axis, wherever the x-intercepts are. Now be careful, this being positive doesn't mean the graph has to go up. The graph could have gone this way and have these 2 x-intercepts, and it still has a discriminant that's positive. Okay, that just means the number underneath the radical, underneath the square root, is a positive number. Then you'll have 2 real solutions. If the discriminant is equal to 0, meaning its value is exactly 0, that means underneath the radical will be the number 0, and that means that there will be only 1 real solution, and the x-intercept is the vertex. And again, the parabola could have gone this way, and that still would have been a 1 x-intercept. Whereas here, if it's positive, you get 2 x-intercepts. Now, if you get where the discriminant is less than 0, that means that the discriminant is negative, and that means you'd have a negative number underneath the radical. That means you're going to have 2 imaginary solutions because you're going to end up using I square root to take care of that negative under the radical. And then there's no x-intercepts, and that tells you the graph does not cross the x-axis at all. It doesn't touch here because I have an imaginary x-intercept. So this table is a very good table to find with you just asked for the discriminant. Let's practice. So here it's just find the discriminant, and the question is then give the number and type of solutions. Notice it doesn't ask you to find the solutions. So all we're going to do is just simply b squared minus 4ac. So for part A, b is 11, so that's going to be 121 minus 4 by 2 by 15. That's what the discriminant is equal to. And if you complete that, 4 times 2 times 15 is actually 120. So 121 minus 120 is equal to 1. Now that's not an answer, that's not a solution. All you have to realize is that number is positive, which means there will be 2 real solutions is the answer to this question. 2 real solutions. Okay, let's try part B. Again, we're only doing the b squared minus 4ac. So this is b is negative 30. If I square that, I would get 900 minus 4 multiplied by 9 multiplied by 25. And that's going to be my discriminant. All right. And if you do negative 4 times 9 times 25, that actually ends up being 900. So 900 minus 900, which is equal to 0. Again, that's not a solution. That just tells you that it's equal to 0. So that tells you I have 1 real solution for this parabola. That means the parabola, the vertex is on the x-axis, and there's only 1 real solution, or 1 x-intercept. All right, for part C, to do this, I have to get it equal to 0 first. So I need to add to 3x and subtract the 3, That's going to get me a 4x squared plus 6x plus 9 equal to 0. And if I find the discriminant, it's just going to be b is 6, so it'll be 36 minus 4 multiplied by a multiplied by c, and that's going to equal my discriminant. So 36 and 4 times 4 is 16 multiplied by 9 is 144, and 36 minus 144 is a negative number. It is negative 108, but you just have to realize that that is negative, and if it is negative, you will have two imaginary solutions is the answer when it's negative. All right, so again, we're not asked to find the solutions, we're just asked to find the type of solutions and how many. So again, your only options are it's 2 real, 1 real, or 2 imaginary. All right, you can't have 1 imaginary and 1 real. That wouldn't work for a quadratic because it either crosses the x-axis twice, once, or not at all. This is the homework assignment for this one. Good luck. Have a great day.